this video, we're going to talk about the 6 major types of volcanoes. And I've shown here a cartoon of the 6. And what I want you to notice, first of all, is that they are divided into 2 large groups. This top group is represented by large terrains, not really what you think of when you think of a volcano. And then the second group down here has to do with volcanoes that have a central vent, a place where material exits. And that's probably what you typically think of as a volcano. Another thing to notice on this diagram is across the bottom, I have the approximate diameter at the base of the volcano. So if it lines up over here, it's got a kilometer size base. And if it extends all the way over to here, it can be up to hundreds of kilometers in diameter. So here are the 6 types of volcanoes that we're going to look at. And again, these are the major types. Notice that we have an increase from left to right of silica content and explosivity, because of course we know that magmas are more viscous when they have more silica. So the first 4 we're going to look at are all basalts. And we've looked at 2 of these before. We've looked at mid-ocean ridges when we talked about plate tectonics, and we looked a little bit at shield volcanoes in the last video. We haven't talked about flood basalts or monogenetic fields, and we'll do that in this video. Stratovolcanoes are made of andesite. And then rhyolite caldera complexes are rhyolite volcanoes. So those are the 6 we're going to go through. As I said, they're based on their size and shape and where they originate. Was the magma coming from a single place, or is it coming from a whole series of fissures? So I've numbered these 1 through 6. They're the same ones you just saw, and that's the order that we'll be going through. And the top one, large igneous provinces, sometimes called lips, L-I-P, are also known as flood basalts. So of the large-scale volcanic terrains, what they have in common is they lack a central vent. So there might be many volcanoes, or there might be a long string of magma being generated, such as at mid-ocean ridges. But there's a network of source material, not just a single magma chamber, and generally these are very massive. The other 3 are central vent volcanoes, which again have some sort of central vent, and we have our shield volcanoes, our rhyolite complexes, and stratovolcanoes. And each of these usually has a summit crater. Now, a fissure eruption is something that might happen on the side, such as in this volcano, you can see some magma reaching the side and maybe breaching the surface, and that would be a fissure. So we're not going to really call that another type of volcano, but fissure eruptions often happen, especially in shield and stratovolcanoes. So here we go through each one of these very quickly. Starting with number 1, the large igneous provinces. These are massive quantities of basalt that erupt from a series of fissures, and they form plateaus that are hundreds of meters high, and in many cases spread over a region that's at least 100 kilometers or so. These are sometimes referred to as flood basalts, as I mentioned earlier. Now, these 2 pictures here are from the Columbia River flood basalts in Washington and Oregon. And what you see on the left is a series of basalt flows. The oldest is on the bottom. They get younger as you go up. And so these just stacked on top of each other over time. Here's another view of it where you can kind of see the edge of one of the flows, the edge of another flow, etc. So here's a map view of this Columbia River basalt. You can see it spans through the state of Washington, a little bit of Oregon, Montana. And then there are these other volcanic rocks down here that we'll get to a little bit later. But this is the region of that particular flood basalt. Now, globally, there are lots of examples of flood basalts. We just looked at this one, the Columbia River flood basalt, but there are many other things. Everything shown in purple here is a huge outpouring of basalt. And so what do we think happens? Well, we think that these are fed by massive mantle plumes. So here we have a cartoon, and I know that it's pretty busy with all the words up top, but basically what this is showing you is the arrival of a brand new mantle plume from the core mantle boundary. It goes up, it reaches the base of the lithosphere, in which case there's a huge outpouring of material when that head arrives, and that's what we think are the flood basalts. Then later, as that material has been evacuated from the magma chamber and the plate moves, we get our series of hotspots. Number 2, mid-ocean ridges. We've talked about these before. These are divergent plate boundaries. They have a linear ridge in the central rift here where material is coming out from decompression melting. and they have a broad kind of gentle slope to them, although they are the highest in the center. Now, because the material is coming out underwater, it forms these really unusual features called pillow basalts. And it's magma that comes out and sort of freezes instantly when it hits the water. And up here is somebody standing on some ancient flood basalts. They're very bizarre to see in the field if you don't know what you're looking for. Here's a video of flood basalts forming underwater, and this is a pretty incredible video. I know the quality is not great, but I love the sound effects. And you can just see how that lava is instantly chilling as it comes out. Moving on to our third large terrain type of volcano, we have monogenetic fields. So mono means one and genetic means origin. So these are fields of volcanoes that are believed to have a common origin in terms of the magma source. And there are hundreds of vents and cones. And I want you to pay attention to that word cones. I'm going to come back to it. This is a field in Arizona, the San Francisco volcanic field, and all of these are little volcanoes right here. Every single one is a basalt volcano. Individually, they're called cinder cones, and I'm going to get to that in a minute. So these are, again, thought to be fed by a single magma source, and they're poorly understood in terms of the plate tectonic scenario that might generate this magma. In California, we have some of these fields. This is showing Northern California, the map, if you can kind of see that. This shaded area that says SNB is the Sierra Nevada batholith. And then all of these little dots indicate monogenetic fields of volcanoes. And so I'm going to zoom in on this one right here, the Big Pine volcanic field. And here's one of the volcanoes from that field. It's pretty big. You can see the communication lines down here for scale. And so these are all, even though they're small volcanoes, they're part of a large volcanic field. So now we're going to move on to the central vent volcanoes. And number 4 is the shield volcano. These have low viscosity and they produce a gentle slope. We've talked about this in the last video. Here's one in Hawaii, and this gentle shield shape is formed by lava pouring down gently on the sides and slowly building up this gentle structure. Remember that this can result in A'a and Pahoehoe lavas, and again, they're gentle. So this is a cinder cone. It's also basalt, but it's small. You can see a person here for scale. This one's in California. And these are made of cinders, which are the material that are sometimes blocky and sharp that are thrown out of a volcano occasionally. And cinder cones are kind of unusual because they don't last very long. All of these volcanoes that we've looked at here take millions of years to form and grow. But there's one more volcano on this list that I kind of hid from you. So way down here, we have volcano number 7, the cinder cone. This is basalt again, and it's very small. See how it's down here at the very small end of the scale. Now, I didn't want to add that in because I didn't want to confuse things. I think 6 major types is enough. But I want to make sure that you are aware that cinder cones are out there. Here's one that's in the San Francisco volcanic field I just showed you. This is called the SP crater. And I've actually hiked up this with students. It's quite an intense hike. It's made completely of material flying up and then just falling along the outside. And here's a lava flow that came out of it as well. There have been several famous cinder cone eruptions. One of them that's well known is the Paracutan cinder cone that erupted in 1943. And the story goes that there was a farmer farming his land, and all of a sudden this volcano started to erupt in the middle of his field. And so this is the volcano over here. And within a matter of days or weeks, it was hundreds of meters high. It erupted for several decades. It completely buried this town called Paracutan. This is in Mexico. And then it stopped. So there's a cinder cone for you. They're kind of mysterious. Okay, back to shield volcanoes. So Mauna Loa in Hawaii is a shield volcano, and it is the largest volcano if you count from its base in the seafloor on the Pacific Ocean floor. 10 kilometers high with a diameter of 120 kilometers. Next, we have to talk about something called a caldera. The word caldera is Spanish for cauldron, And it's a deep depression at the summit of a volcano. It's usually formed by collapse. It's nearly circular, and it tends to exceed a kilometer in diameter. Here's a caldera in Alaska. So the volcano is here, and then here this has been filled with water. Here's an even larger caldera in Greece. This is Santorini volcano, and this is 300 miles long and between 15 and 25 miles wide. And again, filled with water because it's a depression. And all of this stuff here that you see, all these little islands, are within the caldera. They're little islands that are being erupted and created. Another example of how a caldera is formed is shown here by this set of cartoons of Crater Lake, Oregon. So in the past, maybe 10,000 years ago, there was a volcano called Mount Matsuma. Of course, we just named it that. There wasn't really anyone to name it. And it erupted. And when it did that, it evacuated the magma chamber underneath, as shown here. As a result, the weight of all of this material here collapsed into that space in the magma chamber. And that caused the circular caldera shape, which later then was filled with water. And there was a little resurgent activity here that created a little island called Wizard Island. So now I'm going to show you a picture of this today. Here's Crater Lake in Oregon, and there's Wizard Island. So I introduced calderas because rhyolites primarily form calderas. Remember, rhyolites are the most viscous and the most explosive of eruptions. These tend to be so violent that they blow everything away, and you're just left with this big caldera, this big hole. So here's a caldera in Alaska, and then here's another cartoon just showing how exactly these things form. Yellowstone in Wyoming is an example of a rhyolite caldera. It's one of the largest active volcanoes in the world, and we're going to have to finish this in another video. Sorry.